As you can see, is design, project design, digital twins, and digitalization, artificial intelligence. Well, a lot of very interesting things. All the speakers are ready, and according to the recommendation of Slovenko, I will use the app to present all the speakers. Probably, if you don't use until today the app, is a good way to see a lot of things. In particular, I will use for present Ersun Gohana. Ersun is I read I know you perfectly. All the people involved in this session was involved in the first and on the second International Conference on Asphalt 4.0. Well, thank you. Ersun is an expert in laboratory equipment and digital infrastructure. Currently holds the position of Senior Manager Sales at Infratest. And serves as the CEO of Infratest with a strong background of this field. He has authored a wealth of articles and is a regular participant, I confirm that, in technical conference and events. Ersun's professional profile also includes active membership and associations in the field. He is a member, for example, of the General Council of the European Asphalt Pavement Association, EAPA. Additionally, he is affiliated with the Road and Transportation Research Association in Germany, and further demonstrating his commitment for staying engaged and connected with the industry. One more time, again, thank you to be here. The title of the presentation of Ersun will be Digitalization in Asphalt Road Construction, Special Feature, Possibilities, Limitation. Please, the floor is yours.
So, good afternoon, ladies and gentlemen. It is 5 to 12. I can also say good morning, ladies and gentlemen. I'm the last presenter before we go to the next part of the noon. I would like to know who of you knows and uses ChatGPT. Oh, it's okay. It's a lot. Perfect. This sounds very good. So, this is what I also do. I use ChatGPT very often, to be honest. I use it as a brainstorming friend and something like this. And this is normally, in former times, I always ask Google. I ask Google, what is XYZ? What is this? And meanwhile, I ask ChatGPT. And this time I did the same. So I asked ChatGPT, okay, what is the best definition of digitalization? Because this is one of the topics which we have now. And this is what ChatGPT told to me. I have to read it there. I cannot read it here. This is very small, our screen, and then I have problems with my eyes, so I have to look to there. The best definition, or I can do it, the process of using digital technologies to change a business model, optimize operations. I look better without, right? Improve efficiency and enhance customer experience. So, it's nice to have, but I think this is the general description of digitalization. So I asked ChatGPT, okay, tell me what is the description of road construction or for road construction. And this is something I think it's better. It's the integration of digital technologies such as sensors, automation, data analytics, and real-time monitoring, design, construction, XYZ. So this is something I say, okay, if I take a look, we will hear about these topics today and tomorrow. We have the topics of sensors, automation, data analytics, real-time monitoring. This is good, this works. My personal definition is digitalization has to make our life easier. This is, for me, what it has to be, not more, not less. So, starting with these topics or with these words, I would like to come to our field of work, the quality control. As I always say, we have these 3 pillars of quality control. It is starting with the mix design, the production control, and the field control during and after paving. I have only 10 minutes, so that means I cannot talk about all these topics, so I picked a few of them and will give you a small overview, and later on you can ask questions, and of course we are during the lunchtime, we are at our booth where you can come and ask the questions and see what I will show you now directly live. When it comes to mix design, it's easy. We make a lot of things in the laboratory, and we make a lot of tests. Take these tests and take the results. And normally, nowadays, more or less, we use still ordinary notepads, or we take an Excel sheet or a software, but somebody has to put it into there, written or using a keyboard. But the next stage has to be and will be and started. The machines and software, etc., has to communicate with each other. This is, I think, clear. It's not a question of if, it's the question when. And this started and will be one of the next projects and topics for quality control engineers in the laboratories. Also using the cloud, getting all data and combine this data in one cloud system and take it out wherever you are, and not being or not having to be somewhere to check it out. So now we come to field control. This is the part where I want to talk more about it, because I think this is what makes all these things, as Ralph said today, sexy. So we have to be more sexy than until now. When it comes to field control, this is for me one of the best. It's not the topic of sexy. This is Sven. Don't tell him. This is sex. This is Sven. Don't tell him. Okay. And Sven looks sexy, to be honest, yeah? So, okay. This is in Germany, because of the regulations, what we have to do. We talked about this also last year in Madrid. We have to take the temperature of each truck during the dump of the asphalt into the finisher. It is mandatory. You have to do this. And actually, at this moment, this is done by people. Yeah? They are going to there with a temperature probe and checking it and taking a note. So you can do this, yes, but on the other side, we are talking about work safety, workers' safety. We are talking about digitalization. We have 2024. It doesn't fit, and it is really dangerous. Yeah? Imagine if you work with 2 finishers at the same time, and somebody is running there around, and the people who are running the finishers, they are in stress. They don't want to somebody who comes to there and measure, etc. It doesn't work. It shouldn't be. So what can be done? You can really use very, very easy methods, but they have to work, of course. Easy methods to check it. You can use, as it is shown here, you can use special sensors, infrared sensors, which detect the complete time, the whole time, the temperature of the dumped asphalt. And we use, for example, special ultrasonic sensors, which detect that a truck is coming, so to know, okay, it is for this truck, and the next value is for the next truck. And then you can get the report and send it directly to the authority, and it's done. It is safe, it is fast, and at the end it saves you money, because people nowadays are expensive and because they are not there. And good people are not there. And perhaps one point back, why is this also very important? We will hear this today. For example, my colleague from Germany, Stefan Haneschweger, will talk about this. The topic of warm mix asphalt. In Germany, it's not only a wish, it is now there, it will come, starting with 2025. We have to produce warm mix asphalt, and at the end of the day, somebody has to check if the asphalt which is produced is really warm mix. The authority wants to see that it is warm mix when it is delivered. The people who have the job to pave have to know, do we get the right hot mix from the asphalt plant, etc., etc. So you have to implement these type of technologies to be on the safe side for all of us. This is, for example, two known companies who have data transmission, or to whom we have data transmission, and it's possible to send these type of data to them. They have different site and plant applications. For example, my colleague later from QPoint will tell a lot of these things, what they are doing meanwhile. And as we have, for example, independent systems, we can log to all of these systems. Okay, now we know asphalt is sent to the site, and we know the temperature profile, etc. Everything is okay. The question then is, what is happening in the pavement during and after paving? This is also very interesting. This is, in my opinion, the easiest way to know what is happening in the asphalt, especially at the beginning. So you can use very ordinarily PT1000 or PT100 temperature probes. Put it during the paving into the on the surface. Pave your hot mix, and you will get directly the temperature profile. Especially, you will see how the temperature decreases. And this is important to know at this moment because things are changing. People working outside, they are used to know how the asphalt and the temperature of the hot mix asphalt reacts when it comes with 170, 180 degrees. They know it. Also, the people who are driving the compactors. But this will change because the temperature should not be anymore 170, 180. It will be something between 120 and 140. I don't know, something like this. And then you will not have so much time to compact your asphalt and your hot mix. So it's mandatory to know what is happening, what is the cooling phase, cooling time of your hot mix asphalt, and know it and monitor it. And this is one of the easiest ideal systems to detect it because it is, at the end of the day, it is economically viable, it is cheap, and it works perfectly. So next point, what you can do, this is also a type of sensors which is used. These are small sensors. There is a temperature measuring system in it, and a battery, and the data storage. You put it, for example, during the paving also, and then you pave the asphalt, and it is in the hot mix. And this one measures the data. And later on, you can go to there and read the data out of it. So as you can see, we have here a blue curve, and we have a red dot. So, and that's the problem. These are, for example, limitations when it comes to sensor technology, and you use it in the hot mix asphalt during the asphalt is delivered hot. As I said, in this type of sensors, you have a temperature measuring system. For this unit, it's not a problem. It can measure up to 260, 300 degrees. But there is also battery in it. And battery and temperature, these are two things they don't like each other. So that means to save the system's life, the system shuts down once you got an extreme high impact, high temperature impact on it. The system shuts down and waits until it's cool enough, and then starts again. And this starts again is by chance. So when it shuts down at 125 degrees, for example, then it waits until it has a safe ambience, and then it starts. And this can be, by chance, 110, this can be 105, this can be 80. And that means that different than, for example, here, with the ordinary, let's call it old methods, yeah, where you can measure the complete temperature range, here you cannot do this because, especially at the beginning, the cool down rate of the hot mix asphalt is very fast, and you miss the most important first degrees. So these type of sensors are very interesting and very good for have long-term monitoring, where you put it into the asphalt and say, okay, for me, I want to know what is the temperature profile within the next 1 or 2 years, and then get the data back. So, but of course, we want to know more. So, we all read newspapers, or meanwhile we don't read newspapers, we take a look to our mobiles and iPads and etc. And what we see is we have a problem. We have a climate change, and there are things are changing. The reason can be X, Y, Z. It's not our topic, but there is one fact, there is something changing. And we have to know what is the effect of this climatic change to our road network. And I'm sure there is an effect, but we don't know it at this moment. What is the effect on the vertical temperature distribution? What is the effect on the thickness design? Because when there is an effect on the temperature distribution, on the vertical temperature distribution, then we have to think, is our thickness design, where we are based on data which we got, for example, depending on country, 50 years, 40 years back, do we still use the right data to make the thickness design? Or the binder types which we use, etc. Topics like flooding and so on. We don't know what is happening. So for this, I took a look and only checked how are because we are here now in Slovenia, how are the climatic zones in Slovenia? Yeah? And even it is a country with 20,000, 21,000 square kilometers, we have 3 climatic zones here in Slovenia. And I think it is very interesting to know the climatic change and the effect of it to these different climatic zones. Or do we have perhaps, according the asphalt and the pavement time, do we have different climatic zones meanwhile or in the next years? So what can we do here? This is the idea, to have a measuring systems which collect the data and sends the data wireless, and you can directly monitor it. And this is, for example, this type of artificial cores which you can use. They measure the temperature constantly, transfer the data wireless, and they have a really easy installation into existing systems. It's, as shown here, very easy to take it. You take a drill core out of the existing roads, you put the artificial core into the existing roads, you backfill it with the resin, and that's it. There's nothing else to do. Then you connect the artificial core with a gateway, and the gateway sends all the data directly into the cloud, and from there you can get it into your existing system. And interesting here is, here you can use, for example, the so-called LoRaWAN technology. The maximum distance between the core and the gateway, outside regions, motorways, etc., can be up to 15 kilometers in open area and 2 kilometers in cities. Just to show how things like this look like, it's one of my last slides. This is a temperature profile which we measured in Brackenheim in front of our factory. And what you can see is that during the noontime, the shadow of the tree, what you can see there, is directly on the sensor, and there you can see the peak, which goes down approximately by 10 Kelvin, and this is only the effect of one tree. So we don't know how the effect is in cities, for example, where you have shadow systems, yeah, because of buildings. Perhaps we are over-designed, or not thick enough, because we have special areas where you have only pure sunshine without any shadows, etc. So conclusion, it's my last three words. I think, and we will see it the next days and today, we have digital technologies which enable us to understand asphalt better than ever. Because until now, there were always, sometimes you make everything right. Design is right, paving is right, production is right, but it doesn't work. And you don't know why. But now we have possibilities to understand why. We have to be open for this. This is a topic which we had also today in the morning. We have to be open to try new technologies, because if we don't try new technologies, if we don't act now, we react tomorrow. Thank you very much.
Congratulations again, Erasmus. Very interesting. Well, the next speaker is also well known. It is Natasha. Natasha Poeran. Natasha, I read also in the app, born in the Netherlands, achieved her master's degree in road and railway engineering in Delft University. During her study, discovered her fascination for materials, the behavior of the fundamental challenge therein, especially for the bitumen and asphalt. Welcome to the family also. And recently, with Berwick, they create a company. The name of the company you can see is Partnering Solutions. In order to further main topics in the industry, like end result verification, among others, Natasha combines knowledge on both theory and practice to design and customize research projects. Works toward a transition in the paving construction industry from implicit craftsmanship to explicit automation. Please, the floor is yours. Thank you.
So, good afternoon, everybody. Since I'm the first speaker to start in the afternoon, I just... Works. So, Ersun, I have to thank you for the perfect introduction for what I want to discuss with you today, because where you left off, I start. I think we all agree also, based on the presentations we saw earlier today, that everything is changing. We call it revolution, we call it transition, we call it change. Doesn't matter. These changes, they occur on different levels. There are global changes, there are changes taking place in our own pavement sector, and these changes, they take place in different categories as well. We see a big transition in circularity. We are here together because our digital technologies and our, let's call it our digital smarts, they are developing much faster than ever before. And because of that, technology is also thriving. And you hear me hesitating when I say because of that, because the thing is, all these transitions and all the results that come from these transitions, they are interrelated. So just to give you an example, Ersun, you just talked about, for example, the temperature distribution in the height of an asphalt layer. We know this is an important parameter. We know we need to measure it, but only if we apply a measurement system, evaluate the results, and learn from how this measurement system works, and we learn if this data and how this data is effective for us to implement it in our practice. That's the only way we move forward. But it means that there's a direct relation between the digital knowledge and the knowledge of new technologies. If we implement this digital and technological developments, most likely we will be able to make more circular pavements as well. They will be more durable. But the thing is, and that's exactly the thing, all these changes, they take place surrounding us. But we are pavement people to begin with. So everything we do, at least for me, I can only speak for myself, I view from the perspective of the pavement. So where digitalization, Ersun, has to make life easier for you, for me, it needs to help me to manage the performance of the pavement throughout the life cycle of this pavement. And ideally, I want to be in control as early in the process as I can be. And then we get to a little bit of a difficult point, because we start to talk already about definitions. If I talk about the pavement life cycle, For some of us, maybe this starts when we have a physical object. We actually have a road that we can touch, that we can drive on. In my sense, the pavement life cycle starts much earlier. When we start to design, even when we start to specify, because when we specify what the pavement should adhere to, we specify our needs and we specify what we expect from this object in the real world. So ideally, I would want to be knowing that if I specify at the beginning what I want my pavement to be, or how I want my pavement to perform, I want to be sure that when the pavement is constructed and when the pavement is used, without any hesitation or without any doubt, the performance that I specified will also occur in real life. But if you then take a look at the pavement life cycle, you see it's a long chain of different stages that we have to go through. And to get from stage to stage to stage, you see in the bottom left corner this triangle between the S, the O, and the A. The S stands for the stage, the O stands for the object, which in this case is our pavement, and the A stands for the activity. What this graph says is that to get the object from one life cycle stage to another, we perform activities. The way we perform these activities will have an effect on the performance of the pavement in the end. So if we want to be in full control, we do not only need to look at what type of measuring systems do we have, and we also need to look at what measurements do we actually have to do that will allow us to be in control of the activities that we are performing, because by performing these activities, we are making our object. And the funny thing about performance is that it's a resultant. The thing that's most difficult, I think, in our pavement community is that we can do, on the front side, we can do everything right. If we deliver our pavement, the quality can be very, very high. But never, ever, ever does it guarantee that the performance will be good as well. So there's a big difference between quality and performance. And I state that in order to perform, you always need to be aware of the quality paradigm. It's not only what you do and what you put in, but it's also how you do it and how you put it in that will allow the quality of your end product to be as good as it can be. And then the other interesting thing about our pavement life cycle that also hampers us to really be fully in control of this pavement performance is the fact that we try to reach for circular processes, but within our pavement process, we cannot deny the linearity and the viscoelasticity, for example, of the viscoelastic nature of our asphalt mix in the basis. It means that everything in this pavement life cycle, and I'll go back, every time you perform an activity to go from one stage to the next stage, you provide an input for the next stage, and in the next stage, you will always provide an output that will be another input for the stage again. So it's a continuous cycle, and it means that if in the beginning you have some measuring fault or some measure mistake, the only thing that will happen is your mistake will grow and grow and grow and grow and grow. Till at the end, you have your pavement, and maybe it fails in 2 days. You will never be able to find out why. You do the same thing 2 weeks later, and that pavement will lay there for 20 years. Don't know why. That's not making my life easier. So, I think the first big step we need to take is to be aware of these relations in the life cycle stages. We need to make them explicit, because this will allow us to define for every phase in our life cycle and for every relevant activity that we perform in our pavement process, what are the relevant parameters to measure? For example, the temperature in the layer, it's very relevant if you are processing the material. So if you have the bulk matter on the site and you want to make it into a preformed layer, it's very important to measure the temperature. But is it, for example, is it also very important to measure that temperature in the use phase? We don't know, right? But by making these functional interrelations explicit, we at least, if we apply new techniques and we apply new methodologies, we have made a place for that data and that results to be relevant, to be used and to be analyzed. Because now, everything I just saw this morning, for example, also, we are really innovative together. There are a lot of new techniques and new measuring systems coming up every day. But what we fail to do together is to make sure that all the knowledge that we gather together in all the countries can be analyzed and can be evaluated in one and the same uniform way. If we manage to do that as pavement people, then I think that would be a big win. And I think, that's what I forget, if we can make these relations explicit for every phase of the life cycle, we also need to understand each other. And this is what I mean with semantic interoperability. We can talk about asphalt, we can talk about bitumen, but if I'm in America and I talk about asphalt, I'm not really sure if I'm talking about a binder or a mix, or there's a lot of difference also in our definitions. So here, for example, I say we need to make let's say our pavement lexicon. And the only way to do that is to really define also what do we actually want to measure. Because we know we are working on a pavement. We know we want to be in control of pavement performance. But what does that mean? What's the function of the object? What's the function of the pavement? And which properties for that specific pavement in that specific situation are relevant? It's always different. To achieve semantic interoperability, another building block of the functional framework is a so-called ontology. Here on the left, you see the ontology, but I will not get into it. I will refer you to my colleague later on, Barry. He will talk about knowledge graphs and ontologies, and he will tell you a lot about this. This is my last slide, and this is just a general view on what I believe the contours of such a fundamental framework look like. You have on the left side the ontology, and this ontology is the relation of things. You can specify this ontology for every stage in the pavement life cycle. It means that for every stage in the life cycle, all the relations between the relevant properties at every scale in our decomposition level of the pavement are available, they are uniform, and they are structured. For now, I have shown you the framework for the as-built state, but you can imagine that if we expand this framework to different life cycle stages, also the activities that you see here will be different, and they will also result in different functionalities, for example, in our object type library. compared to the presentations before, I think it was a little bit more abstract, but I really firmly believe that we need to keep doing all of it. We need to keep developing all these new techniques, but we also need to make a uniform base, a uniform platform for ourselves to make sure that all the effort we put in and all the love we put in actually also has the expected outcomes. So I would really like to encourage everybody, think about this. Please share with me your opinion, and maybe next year we can talk about how we can really expand this type of fundamental framework for determining and beoordelen. Well, to control the performance of our pavements everywhere in Europe. Okay, thank you.
Very interesting, Natasha. Your presentation is totally different at the president presentation. Same for me. I will take several minutes or hours to assimilate, but you talk about a very important subject. Thank you. Well, the third I try to do rightly is Jaka Gorisek. That's more or less okay. Let me introduce something. He's an independent expert associate within road management sector for a Slovenian highway and express operator DARS. He finished studying geodesy and geoinformatics with master's degree at the University of Ljubljana. He started his career in field surveying for telco companies in the last 4 years at DARS. He is active in the field of mobile mapping, road data, digitalization, G-systems, and research and development of advanced information system and technologies. And the subject of the presentation, do you have there, digitalization of DARS road infrastructure. Please, the floor is yours. Thank you.
Hello, everyone. Really excited to be here at the 3rd International Conference, Asphalt 4.0. Kudos also to all the organizers for putting together this amazing event with such different topics and sessions. As mentioned, my name is Jaka Gorisek, and in the next 10 minutes or so, I will take you down the road of digitalization of road infrastructure that we are doing at DARS. So just to set the basic framework, we are a motorway management company. We also do tolling and maintenance for our network system. It consists of about 625 kilometers of highways and expressways, and over 1,000 bridges, overpasses, 23 tunnels, and this all serves as an infrastructure basis, of course, for the road traffic. We are seeing more than 35,000 personal vehicles per day, over 5,000 heavy vehicles per day, and these numbers, of course, keep rising year by year. So the road to the digitized infrastructure management is not as straightforward as some of our motorways are, but it has quite some curves and bends that I would like to explore with you today. So first of all, we have different infrastructure elements that we are trying to digitize. Here we are at DARS, we are dissecting them into the road surface, pavement, the structures that complete it, bridges, overpasses, geotechnical structures, tunnels, and so on. And then, of course, road markings, traffic signs, and also noise barriers and other road equipment. Then on the next turn, we can see that you have to take into account different digitalization techniques, methods, and technologies in order to actively or optimally digitize the infrastructure elements that you have. Then on the next band, we get to the digitized data about infrastructure elements. These are usually stored in computer databases, GIS systems, sometimes even digital twins. And all this is then a basis for creating analytics, reporting, predicting the future behavior, and of course, creating maintenance plans. So now in the following minutes, I would like to go through that road infrastructure element by infrastructure element as we see it, to kind of show you some of the more advanced techniques that we are using to help with the digitized infrastructure management. So first, of course, the most important, the road surface. We are interested, of course, in the quality of the road surface or the pavement, and the condition or the damages that appear on this on our roads. For this case, we are using many technologies that are being done from the mobile mapping units to detect or to quantify the state of our road surface. We are then using and combining all this data in expert systems, and then we can create plans for maintaining very high levels of quality and, of course, provide safe pavement for our road users. Then we have, as mentioned, over 1,000 bridges and overpasses. They are all subject to periodical inspections. Next to some of the traditional techniques, we are also doing some of the, let's say, more digitized, more advanced techniques to make our lives easier. Here we are starting to use drones, unmanned aerial vehicles that are equipped with different sensors. It could be optical, thermal, or even LiDAR sensors to gain insight into the structure itself. So here we can then have different 3D models of those structures and can then effectively help ourselves with seeing the conditions of certain bridges and overpasses. Similarly goes for tunnels and geotechnical structures that, of course, provide, that are, of course, another very important infrastructure element that we have. Here we are also using many digital technologies to help with the inspection process. We have fully digitized interiors of our tunnels with laser scanning or LiDAR technology. And in geotechnical structures, we have many IoT sensors installed so we can have live data about the behavior to see how the certain structures are doing or behaving at different points in time. Then we have road markings, traffic signs. This is, of course, a very, very important part of the road infrastructure from everyday users' point of view. We all drive on the highways almost every day. And it's really important to have very well visible road markings and traffic signs, not just for users or for, let's say, regular cars, but also for advanced driver's assistance systems, because they take into account road markings and then help navigate the car with these advanced systems. Here we are using another mobile mapping technology to measure reflectivity of those elements, road markings and traffic signs, and then we can make plans to keep them in the good condition, have them very well reflected, and in tough conditions at night, in fog and so on, that the drivers can more safely use our highways. Of course, one of the things that we are also interested in is the noise levels or noise pollution that also comes from the highway. This is especially important in the highly populated areas with high density of the population. We have lots of noise barriers already installed, and we are doing periodical monitoring measurements of the noise levels. Then we can create visualizations like that show us where we maybe need to improve or add some more noise barriers or make them taller and so on. Then we are also engaged in a very interesting project about digitalization of underground utilities that are also kind of part of our road network, because they provide power and telecommunication to all the traffic systems that we have along our highway. Here we are using ground-penetrating radar technology to effectively increase the positional accuracy of our existing database. And with that, we also hope to minimize the damages that come from, let's say, excavations or some roadworks when we wouldn't have data of such high quality. And then are some other interesting digitalization techniques that are not so specified on different infrastructure elements themselves, but more of as a highway, let's say, a corridor in the whole. So one of those is mobile mapping or mobile laser scanning system. Here we generate two outputs. First one is panoramic images that are like Google Street View type of images that just of our highway system. And the second one is LiDAR point cloud. Here we have a very high definition, high resolution point cloud that can be then based for different plans, analysis, creating simulations. And it allows our employees to make 3D measurements of everything that we have around our road network. And then one of the last cases is also use of some aerial vehicles for creating high-resolution digital orthophotography maps or base maps. This is basically a very high-definition layer that we use in GIS systems and also other systems. And it provides great accuracy, of course, combined with other data types that we have, then can generate a really nice visual help, in the whole process of managing the motorways. But as every process, digitalization has its benefits and, of course, its challenges. Maybe we start with the challenges. These technologies are very advanced, and sometimes they can create quite complex data. And in many cases, the processing part of the data capturing takes quite a long time and is pretty complicated. Of course, there needs to be special knowledge and skilled and educated employees to be able to leverage these digitalization techniques. And then, of course, to use the data that comes from them. But of course, on the other side, there are many benefits to why we are using all of these technologies. First of all, we can make data capture faster, especially for mobile units traveling in free flow. Then we have digitized archive. If you're doing these digital measurements repeatedly, you are generating kind of digitalized archive as you go. You can improve the data quality and also improve the data accessibility. When you have different parameters of your infrastructure digitized, then it's very easy to share it with different stakeholders compared to some older types of documentation that also exist. We're also trying to reduce our presence on the road in cases like when you have to do an inspection of some structure, then if we do it from a mobile platform or even aerial platform, we are impacting traffic way less than we normally would. And of course, we are trying to optimize the conditions of those infrastructure elements during their lifetime. So yeah, that was a quick overview of all kinds of technologies that we use at motorway management. So thank you very much.
Very interesting presentation also, Jaka. Welcome to the EAPA family. Well, for the fourth presentation, we have a good friend also here. I made same thing, access to the app, but well, I know very well Thomas. Thomas Leopold Serra is the CEO of the QPoint Group, a solution provider company for the asphalt industry. In August 2024, Thomas was awarded as CEO of the year 2024 in the area of civil engineering construction software by the international medium EU Business News. Congratulations. This is further proof of his great commitment to develop the asphalt industry into a sustainable industry. Thanks to do that. Welcome, and the floor is yours. Thank you.
Yeah, also welcome from my side. A long title, but in fact, I want to tell you a little bit, does digitalization work in practice, yes or no? And I want to show you an example. And I want to bring you to Switzerland, where we have a client. It's called the PHZ Group. This group has 5 asphalt plants. You see they have a lot of experience in producing asphalts. They have a lot of goals to reduce CO2. They are using a lot of REP materials, and they have 5 asphalt plants and 2 recycling centers. So a very good example if they are possible to digitize their processes and which benefits they are getting from that technology. If you look on the homepage of that company, you see a statement which you see at many other companies. Innovation is a topic, innovation is something what we are doing, but the question is, are they really doing that? And so if you look closer on their website, you see directly on their homepage that they have a link to an app. This app is the communication and the link to their clients. So you can download this app, and then the digital communication between the construction companies and the asphalt plant is automatically initiated. So a very simple approach for the asphalt plant to integrate their clients into a digital workflow free of charge, without cost. Just a very small preparation behind the scenery, but it takes only some hours that the clients are online, a very short training or an online training to see how this app is working, and then they can start ordering and managing their processes in a digital way together with this asphalt plant. So how does this work? So in this app, you can create your asphalt project, you enter your basic data, and this data are shared to all people who are joining that workflow. It's not saved on the stored on the app, it's saved in the cloud, and so everybody who is connected can get access to that data. In the second step, they are creating their orders, and these orders are automatically transferred when the time is coming to pave this road, automatically transferred to the asphalt plant. There are some details about the quantities, delivery dates, everything what you need to produce in the correct way, but everything also for the construction companies needed to pave in a correct way. And these things are working together. So this information will be passed then to the asphalt plant, one of these 5 asphalt plants. And here in the asphalt plant, it's very quiet. Nobody is phoning, nobody is reading emails or WhatsApp. They are reading the digital orders in their system. And so they get a lot of information about these orders. They get the information about the current utilization of the plant to see if they can produce it. They can communicate with the construction company in a digital way, not using a phone. They just write a message in the system, and then the construction company sees if this production is available, if this is possible, if there are some changes. Everything is traceable and in a digital way. The advantage for the group is that they have a forecast about their production quantities, because they were able to convince the clients not to give only to enter the demand for the next day or the day after day. They plan in advance the next weeks. So they have, we call this in our solution, non-binding requests. It's just an idea. I want this amount of asphalt in 2 weeks. But the advantage for the asphalt plant is that they can see what they have to produce in the next weeks. They can plan their raw material, they can plan also their production and all these other things. So we have the short-term planning, the middle-term planning, and the long-term planning based on this digital data. A very important thing is then, after the production, to analyze the data, what has happened really during the production. So what we are doing is we are linking the control system, the production systems together in one database, and visualize then in dashboards, for example, the energy consumption of the production. And you can compare it then in this group to find out where is the production more efficient and where not. Or we export this data to external applications, so you build your own reports and statistics, also a very important point. You see here some examples analyzing the temperature during the production, analyzing some other figures during the production to see if the production is running well or running not so good. Here are some statistics. Maybe it's too small to read, but you see statistics about the used material, the used products, the large customers. So it's easier to do that because when the data are available in a digital format, it's not necessary to enter it in an Excel sheet or somewhere. It's just there in the database, and you just start your report, and you have all the details about the whole group. Very important is energy consumption. You see here a statistic of one plant where you see the different usages of energy, gas, electricity, other energy, and in our solution you can also compare different plants based on this energy consumption, which is very important to see and to manage your plants in an efficient way. Here we have the batch protocol, and it's too small to read, but you see this green and this orange fields, which means if it's green, then the usage of this aggregate was better than expected, and if it's red, it was not so good than expected. And this helps you if you see everything is red, then something is wrong in your production, and you can optimize and find out what are the reasons. And if everything is green, you know that you work in a proper way, and you also fulfilled your target values in this production. So a very important point is the transport. So we are tracking also the transport, or the company is tracking the transport. So you see on the map when the trucks are coming to the construction site, and for the plant, it's very important when the trucks are coming back to the plant, because then they can prepare the next production lot, and so there is no space between the loading procedures. Yeah, what is the summary? It's a very good example that digitalization is really working in practice. It's not a theoretical thing. You can use it. And it brings a lot of benefits to this group by integrating all the customers. And in fact, they are getting 90%, more than 90% of their orders in a digital way. Nobody is calling them. They're just getting everything in this digital way. And so they can manage their plants in a very efficient way, and they can use this data to optimize their plants. Let me finalize with a statement of the CEO of this group, and you see the best thing is that he has a transparent workflow, not only in his company, he has a transparent workflow together with his clients. It gives him the possibility to operate his plants in a very efficient way. If you're more interested, we have a stand in the lunch area where you are then joining after the last slide. Or tomorrow we have a workshop also here where I will explain a little bit more how the system is working. Thank you very much for your attention.
Well, congratulations again, Thomas, for your very interesting presentation. We arrived to the last one. Is another good friend. Is Berwig. I will make exactly the same thanks to the app. Please use the app. I see the screen. We are a long number of people involved. Do you have the possibility? Here we have the privilege to be in contact with all these people. but probably you don't know this possible to link to social media or directly like a WhatsApp without nothing, only the app. Send the message, send the question, be in contact. I consider on the past when it's a privilege and do you have in your hands. Well, Perwig, I will try to remember because I know you very well. Born in Suriname, achieved his master's degree in University of Delft also, several years ago, not too much. In his first professional occupational years as a road management consultant, he developed a special interest in looking at the challenge in the road paving industry from a broad perspective to achieve progress in the business. For the past 20 years, he has set up and managed of R&D, Research and Development departments, on the Road and Infrastructure Division of Royal Boskalis, Westminster and Van Begen. In 2023, Berwick, together with Natasha, create partners in solutions. We know at least two partners. At industry like end result verification, reliable service life prediction models for open graded surface layers, full process control of asphalt application, asphalt process automation, and payments data and information management systems. From a holistic point of view, this is a word each time I hear holistic, I think about you. All these topics are strongly related and interlinked. By appointment, classifying and optimizing these relationships works towards a transition in the paving construction industry from implicit craftsmanship to explicit industrialization. Please, the floor is yours.
Good afternoon. Juan Jose, thank you for the introduction. I will try to keep it short, in 10 minutes. So if you don't understand me or you don't understand it, please ask questions during lunch because I have to shorten it. My presentation is about road infrastructure knowledge graph, which in fact is the beating heart of a common data platform. And I will go into this because we have heard a lot about data already today. All kinds of data, all new types of data we collect nowadays. But that creates one of our major problems in practice for individuals, but also for organizations, is the problem, and it's about the interoperability of data, the problem of using the data you have available. And the main problem for each and every individual is the data and information overload, which we are confronted with now. It's beyond human, in fact, it's beyond human control. Even with the use of software systems, it is already beyond our control. And one of the things, the other important thing is that relationships between all the data we have available, the data we create, the data we collect, is that it's very hard to find the relationships and the interrelationships within this data. It can be about data about the pavement geometry. What is the relationship with that with the data about the properties of the raw materials, the data of the pavement performance, but even what is the relationship between the pavement performance and the resources used to construct the pavement, or the cost of the pavement, between the quality of the pavement and the cost of the pavement. We have all this data in a lot of fragmented databases, but we cannot analyze and use the data, in fact, in real time. So the solution, maybe the solution we are working now on in the Netherlands is to create a knowledge graph based on linked data technology. And what in fact we do is that we create a network of all the data we have available. So like ChatGPT or Google, you can just ask questions to your data environment and you will get the answers. You can do predictions. and you can infer and create new data, but the data is directly available for use. In the Netherlands, we have this vision about creating a common data platform on national level. So, and the main purpose to create this common data environment is to be able to make digital twinning possible, so to stimulate the use of digital twinning and the development of data-driven asset management. I will just go briefly through this. Here is all the data you can imagine which is available. It can be open data, it can be data in all kinds of systems, but it can also be individual data files in Excel. As long as the data is structured, and in Excel you have columns and you have rows, that is kind of a structuring. You can add all this data to your network. So it is directly for you available for use. All this data you can it can be integrated, brought together, you might say, and then the heart of the common data platform is the reference. I will go into the ontologies. The ontologies structure the data according to nowadays standards which are there in place for that. And if you have the data completely structured, you can implement it on the data you have. Then you create the knowledge graph. And if you have the knowledge graph, in fact, that is the platform for all kinds of intelligent questioning, predictions, AI, using AI technology, all those kinds of things. I have to do it with this screen. So how do we create the knowledge graph? This is on this sheet. The heart of a knowledge graph, again, or the backbone of a knowledge graph, is an ontology. I will start with a knowledge graph. A knowledge graph describes the data of concepts, entities, and relationships between the entities in the objective world in a structured way to provide the ability to organize, manage, and understand massive amounts of information. That in the end is a knowledge graph. The backbone of the knowledge graph is an ontology. And we have ontologies on 3 levels. In fact, we have what we call the top-level ontology or foundational ontology. And that ontology preferably is based on a standard. For Europe, it is the EN 70632, Semantic Modeling and Linking. I will just show you an example of the top-level ontology. Then if you implement or if you detail the top-level ontology for a certain domain, in this case, the pavement or road infrastructure domain, then you get the domain reference ontology. And in the domain reference ontology, all the relationships, which also Natasha talked about, are defined. Then the domain reference ontology is programmed into standardized language, RDF in this case, and then you get the operational ontology. So the ontology is now ready for use because it's machine readable. So then the ontology is ready for use, and if you implement the operational ontology, if you implement all the data you have available in the ontology, then you have the knowledge network, which is called the knowledge graph. So this is an overview, in fact, of the foundational ontology, which in this case comes out of the Dutch standard NEN 2660, but that one is exactly the same as the ontology, foundational ontology of the EN 70632 because it has the same author. But the foundational ontology, in fact, structures on top level all the data items you might have. Activities, oh, wrong one. Events, states, information objects, abstract concepts like geometries and things like that, data about the materialized objects, data about the road network. The top-level ontology already defines how those top-level relations are set. Then you've already seen this picture in the presentation of Natasha. This is, you might say, the model, the basic model for an asphalt pavement structure. And wrong again. So here, for instance, all the data you have about the loose mix, for instance, during production, that is called bulk matter, data about bulk matter. Data about the pavement structure on five levels, data about the road network. And in this top, and here you have the materials, constructional materials like an asphalt mix, but then again, an asphalt mix consists of raw materials. All the relationships are set in this basic model. And this, in fact, is an international model. So if you are doing work in this field, I would gladly exchange information and experience about this. So what the ontology does is that it structures all your data. In the standard, there are 4 main life cycle phases, which are here in this picture, and you see all the data is structured in, is completely structured like, so you might say the data is ready for use. Of course, it's very important if you define the ontology and you've programmed it, that all the relationships should be right. And to create an ontology, in this case, for instance, the pavement sector, it will take us years to get kind of a complete ontology, and maybe it will not even be possible to speak about a completed ontology because the world is evolving. But it's very important that all the ontology, the relationships can be managed, of course. So there we use an ontology viewer for that. Here are all the objects which are in the ontology, and for each object you can check all the definitions, all the relationships, and so on, and all the properties of which are in the ontology about that object. You can check those with the use of an ontology viewer. And then if you implement the databases, you get a knowledge graph, and this knowledge graph is a very small one, because no, but I think on the next slide, this looks a bit more like it, but normally it's huge, because the knowledge graph is kind of the network of all the data you have available. And we have, with our first pilot, we have created the knowledge graphs for only a test section. Then, the knowledge graph is supposed to be used, for instance, by organizations, individual organizations, but also on the national level for a country, and even internationally, the knowledge graph can be used. And then we get, in fact, not the chat GPT, but kind of chat about pavement or chat about road infrastructure, because you can also ask all the questions you want to that, you can put them to the knowledge graph. And in fact, the knowledge graph, as it is on this sheet, is the platform for AI, intelligent questioning, inference, and so on, and so on, and so on. This is just an example of the results of one of the biggest pilots which we have done until now, because this is an example of data of the Dutch Ministry of Transport, and in this knowledge graph there are now about 100 100 different databases are already linked to each other into a network. So all the data of these 100 databases and data files is directly available for analysis, as you can see some of those in this sheet. So some recommendations. If you are involved in this work and you are in fact starting to be, if we talk about Europe, use the European standard 17632, semantic modeling and linking as the foundational ontology for the development ontologies. Why? Because then it's rather simple to link your ontology to the ontology of another organization, of the ontology of another country, and so on, because they are based on the same foundation. Then, since big data is also all about reuse of data, try to find existing ontologies and try to use those existing ontologies, because then you don't have to think completely from scratch about the relationships within a certain domain. So try to reuse and make use of already existing ontologies. And of course, now we are here within this community, related to the community of EAPA. It's recommended to set up an international platform as an open space to publish and manage ontologies. So it makes it easier to reuse the ontologies. And another grass for the road industry. So this is my last sheet. Thank you.
Well, we are quite finished. We have several minutes. According to the program, Slovenko, we have 5 minutes, 7 minutes, something like this, before lunch. We respect the schedule for the lunch, but well, this is your opportunity if you have some comments or some questions for the 5 speakers. If you wish the speakers to be here, to remember you, please be with me. It will be easier to remember. The only thing that you need, please, if someone wishes to make a question or a comment, that they give you the microphone. Don't forget to say your name and your organization if possible. First question, please. First question, someone? 5 people in front of you, and a lot of things to do you wish? No?
Okay. I will ask.
Please, one microphone to Ersun.
So
Feel free. Ask to.
If nobody asks me, I will ask me a question. So, Ersun, thank you for the good presentation. You talked especially only about temperature sensors, etc. And why don't you talk about other sensor types? And are there other sensor types? Good question. Thank you. But difficult to answer, or easy to answer, but a long answer. At the end of the day, we measure physical values. Temperature is a physical value. You can add some other sensors into the pavement. You can measure this physical value, like acceleration, like force, etc. First of all, you have to find a setup how to bring this sensor into the existing pavement or into a new pavement. First thing. So not to disturb the structure, to measure really that what you want to measure is the first thing. The second is collecting a lot of data is one thing. This is what you said. But what do I do with these values? Yeah? Imagine you collect a lot of accelerations, a lot of them, and then you have to make something out of it. Then if you have an idea, then you need people like from universities, etc., coming from the scientific side and work together with them to get a working and a process-safe system out of it. And this is the reason temperature is, let's say, to be honest, one of the easiest parts to measure, but one of the most important. Even if you have an acceleration sensor in it, you have always to combine the measured acceleration with the existing temperature at that moment. And not only at the point, also at that moment. So, okay, thank you very much, Ersun.
Carsten, please. Tadia, if possible.
Thank you, Ersun, for the nice answer.
Thank you.
I have a question to Thomas. Thomas, you spoke about the implementation of digital solutions at mainly asphalt mixing plants. So I'm curious to hear, since I'm in charge of the European Association, how far are we in Europe in this, in implementing these technologies? So really the application of Asphalt 4.0 technologies. What would you say, what is the level of application and which countries are more ahead than others? So give us a map about Europe, how far we are, what we have to do, and who are the leading countries?
Thank you. A difficult question.
Difficult answer.
But I think there are some companies and areas which are really digitized. So Switzerland is one example where 60% of the asphalt plants and the construction companies are working together in a digital way. Other countries are just at the beginning. That's also the reason why we are here, because this is an area where we see that the level of digitalization is just starting, and we see a lot of interest, but the main aspect is to do it. So we have a lot of presentations, but then you have to convince the management, they need a budget, you have to convince the people. They have their experience without digitalization, and many of them say, I have my Excel sheet, what do you want? But they do not see the benefits in the background, so that the whole process is getting better, not only his personal work. So in fact, it's a long way. No country is far beyond, and we have a lot of things to do. And from the EAPA, every conference, every paper, every published document will help to bring digital solutions into the market. And I think it is then beneficial not for the companies itself, it's also for the industry. It's more attractive for young people working in that industry, for example, and all these other things.
Thank you so much. If I can add something, I feel when we create several years ago, 3 years, the first international conference, the idea is to collect critical mass. It's very important, in my opinion, to create critical mass. People, first year was 60 people, 80 people, no more than this. But, well, we are the double today. And the idea is to talk about that. And I feel my personal point of view, at least my experience in Spain, is we need to talk, we need to mobilize, we need to push. You see here, we are 10 people from Spain. Evidently, one part of this responsibility comes from to find together. It's not the normal approach on the past was the administration asked to solve a problem based on this procedure. You do like this. Now it's different. We need to find together a new way to discover together and convince the others. In my opinion, the rule, the position of the associations, evidently not only at national level, especially at European level, is very important.
And I think there's another aspect. We measure many things, and I think a big problem from the users, the people working on the roads, is that they get the feeling to be controlled. That we draw lines and we see who is above and who is below the line. And I think the big job to be able to install those systems will be to take away the fear of the people to being controlled. Transparency is not always positive, especially if you make faults. But at the end of the day, we will improve our quality by those systems, and we have to take away the fear of the individual people to be controlled. Yes. This is very, very important to start up those systems.
Thank you so much. Fully agree. Well, only the last, because we are on time, please.
Then let's go for lunch.
Yeah, no. Please.
No, but to add to that, it's also of course, it's about evolution in the pavement industry. Agriculture is way ahead, but paving, in fact, the construction part is still completely based on implicit knowledge. The individual knows what to do, and he uses it as he has always been doing it. Now we want to understand, really understand what is happening. So we are in the phase that we are collecting the data of the processes. And the next step is to use the collected data, find the right relationships, so we can make the processes explicit. We can really steer on the processes. And that is where we are now. The clients which we work with, they say, okay, it's nice to collect the data with a Q-point system, but I'm not interested in the data. I'm not interested in what is the temperature of the asphalt. I'm interested in the pavement which is finally delivered to me, if it meets my requirements, if it meets the specification. And that is what I want to see in kind of an easy visual presentation or whatever. So we are still working on that, and if we are there to present the data